Okay, so let's start with expressions and operator precedence, how they are used in our calculations in Python. So expressions, as you can see, it is a valid combination of all the operators and tokens in Python. And there are various types of expression that we can see: string expressions, relational expressions, arithmetic expressions, logical expressions, compound expressions. Various types of expressions are there. Now, evaluating arithmetic expressions the most important thing is that we have to look at the precedence of operators, the associativity of the operators in a mixed arithmetic expression. So, as in maths also, we give importance to any expression which is present within a braces. Similar is the case with Python also. If either argument is a complex number, then the other one is automatically converted into a complex number. That means the output then comes out to be a complex one. And if either of the arguments is a floating point, then the other, which is an integer, will automatically be converted into floating point. And if both the operands are integers, then there is no conversion that is needed. So this table is very, very important, which you have to revise. That the parenthesis is given higher importance, then exponent is given, then unary operators are given importance, then all this plus, minus, multiply, divide, modulus, all these arithmetic operators are given importance, then relational, then identity, and then logical operators. Right, so this is descending order of the precedence of operators. So there are some examples that we have to see. If suppose we have got the value 3 given to A and 6 to B, and we write C is equal to B divided by A, then we get the answer as 2.0. Why 2.0? Because a single division sign will always give you the answer in floating point. And if C is equal to B // A is written, then it will only give the answer in integer, because // will always divide and give the quotient in integer. And if B is equal to 6.0 and A is 3, and we write C is equal to B modulus A, we will get the answer as 0.0 based on the floating point. Then in case of relational and logical operators, if we write P greater than Q less than Y, they will always return an answer in true or false. So P greater than Q less than Y can be evaluated as P is greater than Q and Q is less than Y. And then accordingly we can find out whether it is true or false. In logical operators, the higher importance is given to not, then to and last of all to or. So or will give the answer true even if one of the expressions is false, while and requires that both the expressions should be true. And not will always reverse the answer. Example I have given in the slide: 5 less than 10 and 10 less than 5, or 3 less than 18 and not 8 less than 18. So here, first of all, not will be given importance, as we can see in the expression. So not 8 less than 18 is evaluated as, if 8 is less than 18 is a true answer, but because of not it will turn out to be false. After that, 5 less than 10 and 10 less than 5 will be evaluated, because and is given the next importance. 5 less than 10 is true, but 10 less than 5 is false. So true and false in case of and will turn out to be false. Now 3 less than 18 is true, and the answer that we got previously in in 5 less than 10 and 10 less than 5 was false. So false or true will always return true. So by this we come to know that not is given the prior importance, then and then or. Then comes typecasting. It is a conversion of one data type to another, which is also known as explicit conversion. So if B is 3.2, we have to convert it to integer. We will be using int, bracket mein B, so the value will come out to be an integer.